Hello everyone, welcome to this channel. Today I have planned to start a new GATE Aerospace lecture series. I will be trying to cover all the topics which are mentioned in GATE syllabus, so you can make use of this for your GATE preparation. Okay, let's go to the syllabus. In syllabus, the first will be the engineering mathematics. It will be common to all branches. So in that, for us, linear algebra, calculus and differential equation, and one more thing is very important, which is called numerical methods. Most of the questions till now have asked from these four topics only. So in mathematics part you can score more marks so that you can get higher marks in overall. So first we will see the linear algebra. In linear algebra, first we will learn the basics of vectors, and then we will learn the matrix, and then we will learn how to find the rank of the matrix, and then we will find out certain solutions like consistent, inconsistent, etc. And then we will solve some system of linear equations by different methods, and then we will find out the rank of the matrix, and then we will talk about eigenvalues, and we will learn how to find out the eigenvectors. And in this, it is not mentioned the diagonalization and normalization. We will learn that also. So after linear algebra, we will talk about calculus part. In this calculus part, first we will learn limits, continuity, differentiability, and we will learn different curves, how it works, and then we will learn the maxima and minima, and then we will learn how to find out the maxima and minima, and then we will learn the divergence, and then we will learn the curl, and then we will learn different theorems like Gauss theorem, Green's theorem, and Stokes theorem, and we will do some of the applications in terms of numericals so that you can be clear in that. So especially I already told you these four topics are very important. You can score more marks if you know these concepts clearly. So in calculus part we will also learn the mean value theorem, especially the Cauchy mean value theorem, Rolle's theorem, that is very important, and one more theorem which is called Lagrange mean value theorem. So those are very important, we will learn that. So once we complete calculus part, we will come for the differential equation. In differential equation, first we will learn how to solve the first order differential equation, and then we will learn how to find the solution for higher order differential equation by various methods. There are various methods which is specific to the specific problems, and then we will learn ordinary differential equation with constant coefficients, and then we will go for partial differential equation. In this we will learn different solutions like hyperbolic equation, parabolic equation, elliptical equation, etc. And then once we complete this, we will go for the numerical methods. In numerical methods, first we will solve how to solve with the help of Newton-Raphson method, and then we will learn how to solve with the help of regular falsy and bisection method, etc. And then we will learn how to solve the simultaneous linear equations with the help of different methods like Gauss-Seidel and Gauss-Jacobi method. And then we will go for the numerical methods to solve the ordinary differential equations with the help of Euler's method, Runge-Kutta method, and modified Euler's method, etc. So once we complete this, we will go to the next chapter called flight mechanics. Okay guys, now let's go to the flight mechanics part. In this part, first we will see the atmospheric properties, how to find the properties like density, temperature, and pressure in various layers. First we will see that, and then we will go for the various classification of aircraft. It is just a theoretical part, and then we will go for the airplane performance part. So in this part, first we will see how to find out the equivalent airspeed and true airspeed, and then we will go for the various flight instruments. This is also a theoretical part, and then we will go for the drag polar curve, and then we will go for the different phases of aircraft like takeoff, climb, cruise, descent, and landing. And in landing part we will see how much distance which is taken for each phase, and then we will go for the absolute ceiling and service ceiling, and then we will go for the range and endurance for both turbojet and turboprop. How to find out the range and endurance also, because many questions have asked from range and endurance. Last year also one question have asked from range and endurance, so we will learn that. And then we will go for the Venn diagram. So we will find how what are the velocities, like corner velocity, and then different regions are there, safe region and all. And then we will go for the what are the wind effects, like headwind, tailwind, crosswind, how these winds affects the airplane path and its airplane performance. Once we complete the airplane performance, we will go for the stability part. So in stability part, we will first see the side slip, roll and pitch, and then we will go for the longitudinal stability, stick fixed and stick free, and then we will go for the directional stability, and then we will go for the lateral stability, and then we will see what is the best position of vertical tail and how it affects the stability. And then we will go for the different effects like diagonal effect, wing sweep. We will basically learn what is the contribution of diagonal in all the stabilities, like what is the contribution of diagonal and sweep effect in lateral or longitudinal or directional stability. And then here mostly we will focus on all the stability derivatives, because many questions are asked from stability derivatives. This is very important. Stability part, I expect one question from this year also. And then in dynamic stability, there is less question have asked. After flight mechanics, we will go for the space mechanics. So this is also very important part. Many people will neglect this, but it's very simple. Only basic questions are they are asking from space mechanics. So in this, first we will learn the different types of orbit, like parabolic, elliptic, hyperbolic, circular, etc. And then we will determine how to find the velocities on different orbit. And then we will find out the orbital period, what is the time required to complete the one orbit. And then we will find out delta V, which means the change in velocity required to transfer from one orbit to another. So we will learn that how to find out the delta V for different orbits. So from that many questions have asked delta V part. So we will learn that. So after this we will go for aerodynamics. So in this, every year there are many questions have been asked. So first we will see the basics of fluid flow. In that we will learn the mass, momentum and energy equations. These are the conservation equations which are necessary to solve any problem in fluid mechanics. And then we will go for the potential flow part. In that part we will see source, sink, doublet, line vertex and their superposition of all, which means the combination of sourcing or source doublet pair, etc. And then we will go for the airfoil. In this, first we will learn the airfoil nomenclature, and then we will go and find how to find the lift and drag coefficients for an airfoil as well as a flat plate. Then we will go for the thin airfoil theory, and then we will go for the Kutta-Joukowski theorem, and then we will learn about the finite wing theory. This is very important part. So a lot of questions have been asked. And then we will go for the induced drag, how to find the induced drag and all. And then we will go for the Prandtl lifting line theory. So in fluid mechanics part, in addition to this, we will go for the boundary layer theory. In that we will learn what are the thickness, like momentum, energy, thickness, etc. And then we will go for how to find out the boundary layer thickness. So we will learn many things from here. Boundary layer, of course one question should come from boundary layer, not should, one question usually come from boundary layer, especially from the thickness part. So after structures we will come for the propulsion. So in propulsion, first we will learn the basics of thermodynamics, especially the first law, second law, third law, okay. And then we will go for the boundary layers, especially the thermal boundary layer and heat transfer. It will be a basic part we will cover. And then we will go for the actual propulsion, especially aircraft propulsion. So here we will learn, first we will learn the different cycles like turbojet cycle, turbofan cycle, turboprop cycle, etc. In that we will learn how to determine the thrust efficiencies, what is the fuel air ratio required for combustion, etc. and what is the specific fuel consumption. All those things we will learn, and then we will go for the ramjet engine. Here also we will learn the cycle analysis, and then we will find out how to determine the properties in each components like diffuser and nozzle and combustion chamber, etc. So, and then we will go for the thrust augmentation, especially afterburner in both turbojet and turboprop. What is the delta T, which means what is the additional thrust we are gaining. We will learn that, and once we learn the aircraft engine part, then we will go for the axial flow compressors. So, and then go for the axial flow turbines. In both the sections we will learn how to find out the work required and work gained, and then we will learn what is the compression pressure ratio obtained, and then we will learn the stage efficiencies and overall efficiency, and then most part is degree of reaction. We will learn this. So we will learn that degree of reaction and how to find out the degree of reaction. And in both turbine and compressors we will learn that. This is very important part. Many questions have asked from degree of reactions. And then we will go for the centrifugal compressor part. Here we will learn first the various components and how it's working, and then we will learn what is the work obtained, and then we will learn the efficiency of the centrifugal compressor. So once we complete the propulsion, especially aircraft propulsion part, we will go for the rocket propulsion. This is also important. First we will learn the thrust equation, and then we will go for the efficiency of rocket in terms of specific impulse, and then we will go for the how to compute the drag and gravity loss, and we will go for the multi-staging of rockets, like one staging, two staging, etc. till multi-staging. How to determine the velocities like delta V required for each stage, and then we will go for the classification of rockets, especially solid and liquid propellant rockets, and then we will go for the injectors and what is the pressure drop in the injector and what is the size of the injector required. We will learn that. That is also important. We will learn that. And then especially we will go for, in chemical propulsion, we will talk about different combination of chemical propellants and its uses and all. So it will become for a 1 mark or 2 mark maybe. That's it. So I hope you like this lecture series. So first lecture, this is my so I hope you like this lecture. This is my first lecture. So from tomorrow onwards I will be uploading a series of lectures starting from aerodynamics. So I will be explaining you with a clear concept, so that you can make use of this lecture series and do well for the gate and achieve your dreams. So please subscribe this channel. So your subscription will be motivating me. So please do it. Thank you.